Hello everyone, our next topic is mesh analysis. This mesh analysis is applicable for planar circuits or planar networks. Planar circuit means circuit should not have any jumps. That means if you observe these two circuits, here there is no jumps in anywhere. But here if you observe this is jump here. Okay, that means this resistor is connected from here to here in air. It is connected in air, so it is non-planar circuit. So for this type of circuits, mesh analysis is not applicable. Only for mesh analysis applicable for only planar circuits. Next one, nodal analysis. This technique can be applied for both planar and non-planar circuits. It is beautiful technique and very important technique in the circuit analysis. Now we will solve some problems on these techniques. First question is, find the power dissipated across the 4 ohm resistor. This is the given circuit. Here we have 3 loops, totally 3 loops. This is one loop, this is one closed loop, and this is another closed loop, and this is another closed loop. Mesh analysis is nothing but KVL plus Ohm's law. Similarly, nodal analysis means KCL plus Ohm's law. Okay, now this is the circuit. First consider 3 loops. So this is loop. Let us assume currents, loop currents. Okay, I am considered this is I1 and direction is in clockwise direction. Let it be loop A. Next direction is clockwise direction. This loop is I2. Let it be loop B. Next one, this is loop C, third loop. Current is I3 and here it is loop C. Okay, here this is loop current. Okay, this loop current means from this node this current is I1, from this node to this node. Okay, here it is I1, here it is I1, here it is I1, here it is I1. But in this branch the current is not I1. Okay, this current is coming like this current is going like this. This combination of these two currents flowing through this 6 ohms. Okay, now if you observe here, this is I2. I2 means from here to here same current is flowing, I2. This loop current is flowing through this branch but not this branch and this branch, because in this branch the combination of these two currents, in this branch combination of these two currents. Similarly here it is I3, same current is flowing from here to here, because no common elements for this current and another current. So this current is flowing in this branch. But here in this branch, combination of these two currents. How to find current flowing through these 2 ohms, 6 ohms and 4 ohms? If you observe here, this node, apply KCL. Let it be I2 ohm. If you apply KCL, what is the KCL? I2 ohm. So what is incoming currents? I1. What are the leaving currents? I2 ohm plus I2. Now what is I2 ohm? I2 ohm is equal to I1 minus I2. That means if you observe here, this is I1 positive, means if direction is considering like this, same direction is I1, opposing direction is minus I2. Understood? Same here. This, let it be I4 ohms. Okay, here this is I4. What are the entering currents? I4 ohm plus I2 is equal to I3. Now from this, what is I4? I4 ohm is equal to I3 minus I2. I3 minus I2. See here, this is I4 ohm. This current is in clockwise direction, that means same direction in the I4 ohm. So the I4 ohm is equal to same direction. So this is positive, this is positive. But this I2 is opposite to the I4 ohm. So this is negative. Similarly, same. Let it be I2 ohm. So from this, what is I2 ohm? We can say directly I2 ohm is equal to same direction current is I1 minus opposite direction current is I3. This is I2. Now, apply mesh analysis for loop A. Apply mesh analysis for loop A. Here, current is entering here. So, it is plus V1. Here also current is entering here plus V2. If you apply KVL here, so what is KVL? Minus 8 plus V1 plus V2 is equal to 0. This is by KVL. Now by Ohm's law, what is V1? V1 is equal to IR. So what is I here? Current flowing through this 6 ohm is I1 minus I2. So this is I1 minus I2 into what is resistance? 6. Now what is V2? V2. So V2 is, again it is IR. Current flowing through this 2 ohm is I1 minus I3. I1 minus I3 into 2. So substitute these two equations in this equation. Minus 8 plus 6 into I1 minus I2 plus 2 into I1 minus I3 is equal to 0. Okay, what we are getting? 8 I1 minus 6 I2 minus 2 I3 is equal to 8. This is equation 1. So here what we are doing, by KVL we are getting this equation, and by Ohm's law we are getting this equation. That's why mesh analysis is called as KVL plus Ohm's law. We can write this equation directly by using mesh analysis. Okay, I will show how it is. Now, for suppose, whenever we are applying mesh analysis, consider sources is equal to passive elements. Sources is equal to passive elements. First consider this loop. So what is the source here? 8 volts. So here current is leaving from the 8 volts. So let it be positive. If current is leaving from the source, only in mesh analysis, not in KVL. Okay. If current is leaving from the source, let it be positive 8. Is there any sources connecting to this mesh? There is no sources connecting to this mesh. So 8 is equal to, if you consider this mesh, here I1 is the leading current. That means it is the king of this mesh. Okay, it is the king of this mesh. So here, so what is the resistance here? 6 into, so what is the current? I1. So current is going in this direction and this current is going in this direction. So both are in opposite directions. So let it be I1 minus I3. First consider I1. Why? Because we are considering loop A, that corresponding current is I1. So this is the king of this loop. So consider I1. Next, this is I2. Okay, sorry. Now coming to this element. So this current is going from top to bottom. So this is 2 into I1. Now, so this current is bottom to top. This is top to bottom, this is bottom to top. So both are in opposite direction. So it is I1 minus I3. For suppose, if the current if you assume current direction like this, that is counterclockwise direction, you will get positive here. If you assume this direction is counterclockwise, you will get positive here. See here also, if you assume this direction is in counterclockwise, you will get positive here. So here I am taking all are in clockwise direction. So this is positive and this is negative. That depends on the direction at the branch element. Okay, from this equation, what we are getting? 8 I1 minus 6 I2 minus 2 I3 is equal to 8. Okay, if you observe here this equation, no need to apply KVL and Ohm's law, you can write directly this equation. Now apply mesh analysis to loop B. For loop B, so for this loop, is there any voltage sources here? There is no voltage sources, so sources are 0. Next, consider this element. For this element, what is the current? 0 is equal to 1 into I2 only. Okay, this corresponding, this element current is I2 only. Now consider this 4 ohms plus 4 into, the current is going in this like way. Here I2 is king of this mesh, so here consider I2 direction only. First take I2 direction. So if you take I2 direction, first it is I2. So what is the another current direction? Opposite to the I2, that means it is counterclockwise. So current is I2, this current is I3, both are in opposite direction, so it is minus I3. If it is same direction, you will take plus I3. So this is 4 into I2 minus I3. Next one, what is the next element? 6 plus 6 into, so first consider this current. What is current? I2 minus, what is another current? So this current is going upwards, this current is coming downwards, so both are in opposite direction, so it is minus I1. Now what is the equation? Minus 6 I1 plus 11 I2 minus 4 I3 is equal to 0. This is equation 2. Now for loop B, apply mesh analysis for loop C. Okay, loop B is completed now. Now loop C. If you consider loop C, first consider individual elements, that is 9. Is there any sources here? There is no sources connected to this loop, so sources are 0 is equal to, this is 9. So consider individual elements. First one is 9 I3. Next plus, so what is the element? This is 2. 2 into, so the king of element is currently I3 is king of this loop, so this is I3. Now observe this current direction. This is downwards and this is upwards, both are in opposite direction. So here I3 minus I1. Now consider this 4 ohms. So this is from left to right, but this is in right to left, so both are in opposite direction. What is the element here? 4 ohms plus 4 into I3 minus I2. If you solve this equation, you will get minus 2I1 minus 4I2 plus 15I3 is equal to 0. Let it be equation 3. Now solve 1, 2, 3. You will get currents. I1 is equal to 2.3281 amperes and I2 is equal to 1.5312 amperes and I3 is equal to 0.7187 amperes. Now what is the question? Question is find the power dissipated in the 4 ohm resistor. Okay, find the power dissipated in the 4 ohm resistor. This is the 4 ohm resistor. What is the power dissipated in the resistor? P equal to I square R. Now what is the current flowing through this resistance? You can take I2 minus I3 or I3 minus I2. I4 ohm is equal to, let I2 minus I3. You can take any one. For suppose if you are getting this is negative value, take I3 minus I2. If you get positive value, you can keep it as it is. But whenever in the problems they are asking particularly, that means if they mention direction, you should take that direction only. That means you consider that direction only. Now what is I4? I4 is equal to I2 minus I3. So what is I2 here? 1.5312 minus 0.7187. If you solve this, you will get I4 ohm is equal to 0.8125 amperes. Now what is the power? P is equal to I square R. So current is 0.8125 whole square into 4. So P is equal to 2.6406 watts. Same question by using nodal analysis. First, identify the how many nodes are present in the any circuit or given network. So here this is one node. Okay, this is one node. From here to here, this is one common node. So this is one node, and this is node 2, and this is node 3. This is node 4. Consider one node as reference node. Okay, so always consider, in general we are taking this is reference node. Now at node 1, what is the voltage? 8 volts from this node to this node. Okay, from this node to this node, what is the voltage? 8 volts. Okay, only 8 volt source is connected, so this is 8 volts. At node 2, what is the voltage? Let it be V2 from here to 4, that is node 2, node 4. Let it be node 3. In nodal analysis, if you want to write node equation at node 2, consider that node has at highest potential. This node has highest potential. Current is always flowing from higher potential to lower potential. Current is always flowing from higher potential to lower potential. So from this node, all currents are leaving, because we are assuming this node has a highest potential. So here let it be current I1, I2, I3. By KCL, what is the equation? I1 plus I2 plus I3 is equal to 0. Now what is I1? I1 is equal to, by Ohm's law, V2 minus, here this voltage is 8 volts, by what is the resistance? 6 ohms. Okay, the difference between voltages by resistance. Now what is current I2? I2 is equal to V2 minus V3 by 4. Similarly, what is I3? I3 is equal to V2. Here it is reference node, means that means it is at 0 potential. So V2 minus 0 by 2. Substitute all these current equations in this equation 1. You will get V2 minus 8 by 6 plus V2 minus V3 by 4 plus V2 by 2 is equal to 0. Now what is LCM? 12. 2V2 minus 16 plus 3V2 minus 3V3 plus 6V2 is equal to 0. You will get 11V2 minus 3V3 is equal to 16. Equation 2. So nodal analysis means KCL plus Ohm's law. Okay, here we are applying KCL, here it is Ohm's law. So both from the both equations we are getting this equation. So it is KCL plus Ohm's law. Now without writing these two equations, we can write this equation directly from the diagram. Okay, so see that, write the node equation at node 2. Okay, so what is the potential here? V2. Write the node equation for all branches. From current is flowing from here to here because it is at higher potential. So V2 minus 8 by 6 plus this is V2, V2 minus V3 by 4 plus V2 minus 0, that is V2 by 2 is equal to 0. So we can get same equation, this equation directly without applying these two. So if we solve this, you will get this equation. Now write the node equation at node 3. At node 3. So how to write? V3 minus V1. V1 is 8 volts. So it is V3 minus 8 by 1 ohm plus. Now V3 minus V2 by 4, because here we are considering V3, that means we are writing the node equation for V3. So this node is at higher potential. If it is higher potential, all currents leaving from this node. So this is leaving current. What is the current? V2 minus V1 by 1. Again, one more current is there, that is current is leaving from this node. So V3 minus V2 by 4. Next, another current is leaving from here. So V3 minus 0 by 9. That is, here it is V3 minus V2 by 4 plus V3 by 9 is equal to 0. If you solve this, minus 9V2 plus 49V3 is equal to 288. Let it be equation 3. Solve 2 and 3. Solve the equations 2 and 3 by using calculator. Solve 2 and 3. You will get V2 is equal to 3.2187 volts and V3 is equal to 6.4687 volts. Now I want to find out power across that is power dissipated by the 4 ohm resistor. So what is the power dissipated in the 4 ohm resistor? P is equal to V square by R. Now what is the voltage across this resistor? Let it be V 4 ohm. Apply KVL. Okay, this is closed loop. This is V3. Okay, from here to here. This is V2. Okay, from here to here, this is V2. From here to here, this is V3. Next, this is V4 ohm. If you apply KVL, what you are getting? Minus V3 plus V4 ohm plus V2 is equal to 0. From this, what is V4 ohm? V3 minus V2. Okay, substitute in this equation, that is V3 minus V2 by resistance is 4. This is whole square. Now, if you solve this equation, you will get power is 2.6406 watts. Okay, in both cases we are getting same value, that is same power dissipation. This is about the mesh analysis and nodal analysis. From the next video we will discuss more number of problems on the same concept, because it is very important concept, mesh analysis and nodal analysis. Thank you for watching.